Hey, let's look at our MT8 LT4 seminar on rational exponents. First thing I want you to do, I want you to do the first 5 questions so we can go over them in class. And woohoo, that's what we're going to take a look at. Now we're going to refer to the launch lesson in your textbook, but since we're watching the video, I've got it open for us. And in this launch lesson, we're going to look at how we rotate around the sun. We do not rotate around the sun. We rotate at something called an ellipse. An ellipse is almost like a circle. It's just a little bit more oval shaped. How close it is to the circle we call E. E is the eccentricity is what we call. For example, the Earth has an eccentricity of 0.996. That's why before Kepler discovered it was an ellipse, people thought it was a circle, and they were pretty close because it's 0.996. It's pretty close to one would be a perfect circle, so it's not that far off. But when we model it, we're going to use some rational exponents. The d, the distance from the sun, is going to be 2t to the 2/3 power. Hence, fraction. Rational exponents are fractions. Now, when we look at our fractional exponents, we're going to look at these in steps. The first one is this. Most of the time, when we use rational exponents, my denominator is 2. That means square root. So anything to the 1/2 power, that's the same thing as square root. We don't have to write anything in our index, which is this thing right here, this n. We'll learn about that later. But just remember, anything square root means 1/2 power. So if we take a look at question or example number 1, I want to do 10 to the 1/2 power. So I'm going to say 10 is the square root of 10. 1/2 means square root. Now on example 2, I'm going to go backwards. Let me make this a little bit bigger so we can take a look at it here. Notice I got a square root, so my entire radicand, that's the part underneath the square root sign, 7k squared. I'm going to raise that to the 1/2 power. Now I got a power of a power, so I'm going to say that's 7 to the 1/2 power. And notice if I take a power to a power, we multiply, 2 times 1/2 is 1. So we get 7 to the 1/2 times k. And that's your answer. When your index is 2, or when you have a square root, we're going to have 2 for our index. We don't write it, so it just means square root anytime you see that. Now what happens if it's not 2? Well, in that case, we are going to write it with an index, like this one means the 5th root of 18. So I'm going to say, hey, what number times itself 5 times equals 18? So when you have a denominator, that's going to be your index. If I have b to the 1 over n and it's anything besides 2, then I'm going to say it's going to be that root. So 32 to the 1/5 power is the 5th root of 32. In other words, I think, hey, what number times itself 5 times gives me 32? In that case, it's 2. And we'll do a couple of them like that. Ooh, we need... Now, if I look at the 5th root of 243, I'm thinking to myself, hey, what number times itself 5 times equals 243? If I'm multiplying by itself 5 times, it's going to get pretty darn big pretty quick. Notice it's odd, so I think I'm going to guess 3. And notice I said guess. That's exactly what we're going to do. So what I'm going to do in my calculator is I'm going to guess 3 to the 5th power. And we get 243. Notice I've got that nth root. I could actually type that nth root. I'm doing the 5th root of 243. And I get 3. So my answer is 3. And if I take a look at example 4, I'm doing the 4th root of 625. So I think to myself, hey, what number times itself 4 times gives me 625? Well, notice it ends in 5. I wonder if it's 5. So I'm going to try 5 to the 4th power. Oh, look at that. It's 625. Isn't that cool? So we get 5. Now, if I got the 4,096 to the 1/6 power, that means I'm going to find the 6th root of 4096. Now, that's a little bit bigger, isn't it? So let's do some guessing and checking, or just use our calculator. So I'm going to say I'm going to do the 6th root of 4096, and it turns out it's 4. And if I take 4 to the 6th power, just to show you, I get 4096. So my answer is 4. If we take a look at example 6, I'm going to do the 4th root of this fraction. Well, that's really 81 to the 1/4 power over 256 to the 1/4 power. So that's the 4th root of 81 over, I said 8, but I wrote, I said 4, but I wrote 8. So the 4th root of 81, oh, I see what I did. I transposed those. The 4th root of 81 over the 4th root of 256. No, the 4th root of 81 is 3. Have we done that? No, we haven't, but it's 3. The 4th root of 256, I do believe that is, well, let's find out. So let's take the 4th root of 256, and that is 4. So that turns out to be 3/4. You should probably memorize the 4th root of 81 and the 3rd power of 27, because those show up a lot. The cubed root of 27 is 3. Just happens it shows up a lot. And the cubed root of 64 is 4. That shows up a lot. How about example 7? There's a shortcut here. The 5th root of 100,000. Notice there are 5 zeros. So that's 10. 10 to the 5th power means I have 5 zeros, so that's my answer. If you count the number of zeros and you take that root, that's how many you'll have. Ooh, get a little marker there. Okay, we're going to do the next question on the next video, because I like to do 1 page at a time. Although notice we did 2 pages because we didn't have any powers on the first page.